This is our statistics final project. I'm Colin.
I'm Zaki.
And I'm Jake.
So the data set we chose was animal rescue incidents tended to by the London Fire Brigade. We located this data set from the London Data Store, and they collected the data from 911 calls to analyze what, how, and where animals routinely get stuck, as well as provide additional information like location and date and time of the incident. The columns in the dataset first say the date and time of the call, then the type of response, followed by the type of animal that needed rescued, as well as where the animal was stuck, and it finally provides multiple columns detailing the location of the incident. So our research question was, do cats or dogs require a higher notional cost to rescue? The dataset originally was 11,310 calls long. However, we filtered the dataset to only contain rows that have cat or dog in the animal group parent column. After filtering the dataset, it was 7,422 calls long. Our X variable, which is the variable we will manipulate, is cats and dogs in the animal group parent column. Our Y variable, which is the outcome variable, is the incident notional cost in GBP. Our Z variable, which is a confounding variable, is the time of day the incident occurred. So whether rescue calls at night time may cost more than those during daytime. So our X variable, which is the animal type, is a categorical variable and it can be summarized with a frequency table and visualized with a bar plot. Our Y variable, which is the notional cost of rescue, is a numerical variable and it can be summarized with mean, median, and visualized with a histogram. Our Z variable, which is nighttime versus daytime, is a categorical variable and it can be summarized with a frequency table and visualized with a bar plot. So this is our bar plot for the variable X, which is animal type. And we can see that there's 5,573 cats who needed rescued in the data set, and there's only 1,591 dogs that needed rescued. So we can clearly see that the amount of cats who needed rescued is much more prevalent compared to the amount of dogs that needed rescued. So this is our histogram of our Y variable, which is the incident notional cost for each rescue. And we can see that the median cost is around, so the mean is 378 and the median is around like approximately 340. So those are pretty close. And our Q1 to our Q3 is almost 100 pounds apart and also pretty close. However, we can see that the max is 3,912, which shows that there are extreme outliers in this variable.
So we actually want to see the difference between our cats and dogs, which is our X categorical variable. So we use a side-by-side box plot to be able to look at that difference in a little bit more depth. We can see that each group has significant outliers, but cats go a little bit higher. It's a little bit difficult to see the difference in median cost from the side-by-side box plot that we used. So we used a frequency table, which is our summarization technique when using two variables. And we can see that cats have a slightly higher median cost to rescue than dogs, but it's not much more. So we wanted to quantify this uncertainty a little bit and determine if in our sample, which is 500 rescue incidents in London, we want to see if that can actually be generalized to the entire population to form a conclusion as to whether there is a statistically significant difference in the median cost of rescue between dogs and cats. So we operated on a null model and ran a permutation test because we have an X variable that's categorical and a Y variable that's numerical. So first, we were able to see that our observed statistic was negative 6.93. But we don't inherently know if this means anything without quantifying the uncertainty that surrounds our observed statistic. So we constructed a 95% confidence interval, which ranges from negative 10.36 to 11.14, which you can see with those blue bars. Our observed statistic of negative 6.93 fell within the confidence interval, which means that we fail to reject the null hypothesis and do not have sufficient evidence to conclude that there is a statistically significant difference between the notional incident rescue cost for dogs and cats. And the fact that the observed statistic is negative indicates that cats have a higher incident notional cost. but we're unable to generalize this to our entire population, which is all the rescue incidents of cats and dogs in the population, because our observed statistic falls in the confidence interval, and we fail to reject the null. Now, we want to include our z or confounding variable to see if there's actually a difference between daytime and nighttime for these groups. And we did so using classical methods. So we used a permutation test and then used logistic regression to further address uncertainty with the presence of our confounding variable. Here we can see the difference in the notional rescue cost for cats and dogs with the inclusion of our confounding variable, z. So we can see that in daytime and nighttime, there's extreme outliers, but there are more outliers that occur during daytime. Again, it's difficult to see the difference in the medians from these box plots just because our outliers go so high.
And that's why we created a chart with four different groups summarized through our two different variables, which is our animal group parent and night or day. So as you can see, there's no difference between the costs of rescue for the dog group, but there was a difference in median costs, and the median cost was higher during the nighttime by 7 GBP in the cat group. And to assess the uncertainty of the z variable, we created another permutation test, and our observed statistic is represented by the red line, and it falls within the 95% confidence interval once again. We achieved that observed statistic by subtracting the mean cost during the night from the mean cost during the day, which came out to be positive 8.72 pounds, which means the mean cost during the day was higher than the mean cost during the night. And that statistic fell within the interval, within the 95% confidence interval. And we cannot reject the null hypothesis. And this means we do not have sufficient evidence to conclude that there is no difference between the mean cost of rescuing dogs and cats during the day versus during the night. To further analyze the association of the RZ variable, we used logistic regression. And since the variables have to be binary, we created another variable called high cost, which returns 0 if the cost is lower than the median cost, and 1 if it is greater than the median cost. And the coefficient of 0.28 shows that when it goes from day to night, the log odds of the cost being high cost is increased by 0.28. And this finding is statistically significant because our p-value is much lower than the alpha value of 5%. The finding in the logistic regression actually goes against the observed statistic because the observed statistic showed that the mean cost was higher during the day than nighttime, while the logistic regression showed that the log odds of cost being greater than median cost is higher during the night. The disagreeing results revealed that the few extreme high outliers during the day pulled the mean cost during the day up, and this caused the mean rescue cost during the day to be higher than the mean cost during the night, although a greater proportion of the nighttime incidents are included in the high cost. Thank you.